Hey guys, it's Miss Smith. We are doing our flip video on Unit 1.3, adding rational numbers. Okay, I'm going to start off by saying, first let's look at the essential question. It says, how can you add rational numbers? Okay, we know how to do this because we have done this the first and second week of school with adding and subtracting integers. Okay, today we're going to focus on just adding. So let's start off. Adding rational numbers with the same sign. We have done this. To add rational numbers with the same sign, apply the rules for adding integers. The sum has the same sign as the sign of the rational numbers. Okay, here we go. A. Okay, we're hiking for 2 5/10 miles and we stop for lunch. Then we hike for another 5 5/10 or 5.5 more miles. How many miles did he hike all together? Okay, we talked about every single time we have positive numbers, we are going this way in the number line. So let's talk about this in detail really fast. We're going this way in the number line if we are talking about positive numbers. We are going this way from 0 in the number line if we are talking about subtracting or negative numbers. So we need to keep that in our head, and we've gone over this in class. So we need to find what 2.5 plus 1.5 equals. Remember, decimal rules, I'm going over decimal rules also right now, is when we add, we got to line up our decimals. So 2 5/10 plus 1 5/10, we need to line up our decimal, bring it down. 5 plus 5 is 10, bring up the 1, 2 plus 2 would be 4. So he hikes 4 miles. We moved 1.5 units to the right because the second add-in is positive. We'll talk about add-in in just a second. So we started at 2.5 right here, and we moved 1.5 over to 4. Now I went over that in a lot of detail, so the next one I'm going to go a little bit faster. Okay. Alright, Kyle pours 3/4 liter of liquid from a beaker. Then he pours out another 1/2 liter of liquid. What is the overall, okay, keyword, overall change in the amount of liquid in the beaker? So we use negative numbers to represent amounts that change each time Kyle pours liquid from the beaker. Alright, let's start out. Well, we start with negative 3/4 because he pours it out. So if I have a beaker and I pour out 3/4 of it, it's going to be going into another beaker. See, look, Kyle's over here in the picture. So if you look to the right, there's Kyle. He's pouring it out. So that means we're in the negatives. So we start out at negative 3/4, and then he pours out another half. So that means we're going the same direction towards the negatives in the number line. Alright, now this is all review, you guys. Y'all know this. This is all what we've already done, before. So we need to remember how to add fractions here. So if they're the same signs, we add. So we have 3/4 plus 1/2. We need a common denominator. So we're going to use a scale factor of 2. Oh, whoops. Sorry, scale factor of 2 is 1/2. This is already our common denominator up here. Okay? Okay, so then we have 2 over 4. So 3/4, kind of went over here. 3/4 plus 2/4 is going to equal 5/4. What kind of fraction is this? Right? It's going to be improper. So then once we get there, it's going to be 1 1/4. Now your number line here, we started out at negative 3/4, and then we moved over a half. Alright. Let's move on. Alright, next part. Let's go. Okay, reflect. Explain how to determine whether to move right or left on the number line when adding rational numbers. Okay, I'm going to give you a second to think about that. Okay, good. You should have said moving to the right is always going to be towards positives. And you also should have said when we move to the left of the number line, it's always going to be towards the negatives. Alright, now it's your turn. I want you to pause it, and I want you to use your number line to try to do 2 and 3. Okay, and so if you want to work it out on the side, since you should know your rules, you can get that answer that way too. So pause me for a second. Okay, I'm going to start off by doing it on the number line. So if I start out at positive 3, I'm going to put a dot on positive 3. Then I'm going to move 1.5 towards which way? Good, positives, because it's a positive number. So I'm going to move 1.5. So then where am I at? Good, I'm at 4.5. Okay, of course you can add them. What's 3 plus 1? That's 4, and then another half would be 4.5. So you could do it that way too. Okay, let's do number 3. If they have like signs, that means we are adding. Okay, that's the rule, and using the number line might help you more. So I'm going to start out at negative 2.5, so that would be right here, correct? Okay, and I'm moving more towards the negatives, so I'm moving 4.5 away from 2.5. So I'm going to move 4 first, and then I'm going to move my half. So 1, 2, 3, 4, and then I have 1/2 at the end right here. Okay? So then where am I landing at? Good. -7. Now, number line should help you, of course, when you're adding integers, but if you did it without the number line at first, then that's fine too, because we already know these rules. Alright, moving on. Adding rational numbers with different signs. Okay, remembering from last week, let's read this. To add numbers with different signs, find the difference. Now, Miss Hitchcock taught me something that I don't think I said in class, but this is so good. Okay, different has DI. Okay, we're working with different signs this time. We're working with a negative and a positive. So different has DIFF in it, right? And so does difference. So if you can remember that, that can help you too. So if they're different signs, then we take the difference. And then, of course, let me just make sure we know our vocab. What does difference mean? Good, it means subtraction. Okay? Alright, moving on. Let's go to, I'm going to go over a vocab word really fast. Let's go over absolute value. Okay? Absolute value, let's write it over here in our blank space. Absolute value is the distance from 0. And I talked about this with my classes, but I don't know if the other teachers did. I'm sure they did. But it means the distance from 0. Okay, so if I'm 5 away, let's use this number line. If I'm 5 away over here, okay, my absolute value is 5 because I'm 5 spaces away. Okay? If I am -5 here and I want the absolute value, I'm still 5 spaces away from 0. So all absolute value means is the distance. So let's do, 3 examples. Okay, so well, first of all, let me show you the sign. When you see 2 bars here, that means absolute value. Okay? So the absolute value of 5 means how many spaces away from 0 is it? Good. It's 5 spaces. What if I had -5? How many spaces away is -5 from 0? Good. It's still 5. Right? Awesome. What about -20 with lines around it? That means absolute value. So absolute value means how far -20 from 0? Good. It's just 20 spaces. Now, of course, positive. Well, yeah, that's another thing you could remember is when you're taking absolute value, they always end up positive, but we got to know the definition, the distance or the spaces away from 0 on your number line, okay? All right, moving on. Okay, let's read this. During the day, the temperature increases by 4.5 degrees. At night, the temperature decreases by 7.5 degrees. What is the overall change in the temperature? Step 1. Use a positive number to represent the increase in temperature and a negative number to represent the decrease. So we increase and decrease. Of course, y'all should know increase means we go up. Decrease means we go down. So in relation to our number line, that's exactly what we're doing. So if I start out with 4.5, it's going to be right here. And then how many spaces did they move? Good. They moved 7.5 away from it because, remember, if we have negatives, we're going more towards the negatives. We're going this way in the number line. So if I move 7.5 away towards the negatives, I end up at -3, and that's going to be my answer. Awesome. Okay, let's move on to B. Ernesto check for $2.50. Then he deposits $6 in his checking account. What is the overall increase or decrease in the account balance? Okay, first of all, we got to go over some vocab because some of you don't know what deposit means. Okay, when you write a check, you are giving someone money. So this would be, going towards the negatives. Deposit means if someone gives me $6, I'm going to put it in my checking account. I'm going to put it in my checking account. So this would be plus. Now we're going to go over these definitions in a unit in detail, but today just know that deposit means we're adding to our bank account, and writing a check means we're giving someone money out of our bank account. Okay, use positive numbers to represent a deposit and a negative number to represent a withdrawal or a check. Okay, using our number line. If I start at 2.5 and I start at -2 and move 6, +6, which way am I going in my number line? Of course, I'm going towards the positives. So I move 6 this way and I land where? Good, I land at 3.5. Now a lot of you are like, Miss Smith, well, why can't we don't have to use the number line? Okay, well, let's do it without the number line. If I have 6 minus 2.5, I'm going to end up with the same answer I did, right? Borrow. I'm going to end up with 3.5. Okay? Who's bigger? 6. The positives override the negatives, so that's why we end up with positive if we didn't use the number line. Okay? This is exactly what we did last week, just saying. But now we're using number lines. Okay. Since we're running out of time, let's just skip reflect here and let's move on to 6, 7, and we'll go over 4 and 5 in class, because those are some more vocab that we don't have time for on this video. Okay, I want you to pause me. I want you to try these with an answer, and I want you doing it on the number line. So pause me for a second. Okay, you should have gotten -3 for number 6. You should have changed on the number line, we should have started at -8 and then gone up towards the +5. So 1, 2, 3, 5, and we ended up where? Very good, at -3. A half plus -3/4. Well, it's pretty hard, doesn't it? But into common denominators and use the integer rule. Or notice how from 0 to 1 they're split into 4s. So this would represent 1/4, 2/4, and 3/4. Alright, so if I am supposed to be -1/4, -2/4, -3/4. Okay, so if I'm starting at -3/4 and I'm going up 1/2, well, what is 1/2 as a common denominator? Good, be 2/4. We scale it up by 2, it's going to be 2/4. So I'm going to move up. Oh, sorry, I totally went backwards. Okay, we're going to start at 2/4 because it's our first number. That's what we've been doing the whole time. My bad. And I go up 3/4, or back 3/4 because I'm going back towards the negatives. So 1, 2, 3, 4. I end up at negative. Did I do that right? 1, 2, 3. Sorry. Oh my goodness. Of course, I'm doing this video and I'm messing up. Bear with me. I'm so sorry. Okay, 1, 2, 3. Then I end up at -1/4. Oh, I'm so sorry. Okay, good thing we got done with that one. All right. -1. Start at -1 and we go up 7. 1, 2, 3, 4, 5, 6, 7. We end up at +6. Awesome. Okay. We are going to go through this super fast because I've been spending a long time on this video and going through with you, in detail but fast, but we have a lot to cover. So I'm going to cover additive inverse. Okay. All additive inverse means is it's the opposite. Okay? So let's read this together. The opposite or additive inverse of a number is the same distance from 0 on a number line as the original number, but on the other side of 0. Of a number and its additive inverse is 0. 0 is its own additive inverse. Okay, 0 is special, of course. So, all this is saying, guys, is if we are adding opposites, we are always going to end up at 0. So if I give you if I give you $3.50 and then I take it right back, what are you left with? $0, right? So think about it like that. If you are adding opposites, it's always going to be 0. Okay, and I'll let you look at example A and B if you're a little confused, but I think we got it because we're going to do an example right here. Okay, 9. We don't really have to use the number 9. Let's just look at it. I have 2.5. What's the opposite of 2.5? It's negative 2.5. So 2.5 plus negative 2.5, these are additive inverse or the opposite. So it means that we're just going to end up with 0. Okay? These two are 0 because I have negative 4.5 and then I have 4.5. So this is going to end up being 0. Okay? Okay. Moving on. Alrighty, now here's where it gets a little rough. Not really, it's going to be easy, but we did not go over this last week. So now we're going to be adding 3 or more rational numbers. So, going down here, let's read the problem. Tina spent $5.25 of craft supplies to make friendship bracelets. Oh, how nice. She made $3.75 on Monday. On Tuesday, she sold an additional $50 worth of bracelets. What was Tina's overall profit or loss? Alright, step 1. We need to figure out what is negative and what is positive. So if she spent this, of course, $5.25 is going to be negative. She made, what do you think $3.75 is going to be? Good, positive, because she got it back. On Tuesday, she sold an additional. If you sell something to somebody, what does that mean? Yeah, you're gaining it, you're adding it. So, just like we wrote up here, we use negative numbers to represent the amount Tina spent and positive numbers to represent the amount Tina earned or made. So here we have negative $5.25, positive $3.75, and positive $4.50. Okay. Number 1 rule is we group the same signs together. Let's go over the rule again. If I have a negative plus a negative, it's going to end up being negative. Very good. If I have opposites, if I have a negative plus a positive, we're going to subtract and take the sign of the bigger number. So why don't we, get the easy stuff first by adding our like signs together, and then we can do, whatever we need to do for the next step. So here, we are going to add our positives together, which ends up being $8.25. So now let's look at this. I have different signs because I added my like signs and I got a positive down here because we add and take the sign of the numbers. So now what do? They're different, and then difference, which means subtraction, has DIFF in it. So we're going to subtract. So 825 minus 525 is going to end up being what? Good, $3 because it's here and it's the answer. So we subtracted. 8 is bigger because it overrides the negative. So we end up with $3. Okay, down here, I want you to pause me. I want you to try 11 through 14, and then we'll go over it, and then we're done. Thank you so much for bearing with me. Pause me, and then we'll go over it, and then we are finished. Good job, you guys, so far. Okay. What did you add first on number 11? Good, you should have added your like signs. My like signs are my positives here. So I can add 3 and 5/10 plus 2, which would have gotten me 5.5, or 5 and 5/10. So now I have 5 and 5/10 plus negative 1 and 5/10. Okay? I have different signs. DIFF. What does it mean we do? Subtract. Very good. So we subtract. Who's bigger? 5.5. So it's going to be a positive. So we end up with 4 or 4.0. Okay, next one. We should add our negatives this time because these are our like signs. So when I add those together, I get negative 4 and 1/4. Then I bring 3 and 1/4 over, and I end up doing what? They're different signs, so we take the difference, so we subtract. Who's larger here? Good, our negative. So we're going to end up with 4.5 minus, 4 and 1/4 minus 3 and 1/4. Good, you should have got 1. Okay, next one. We should have grouped our negatives together. And we should have gotten negative, what should I have gotten here? Negative 6 plus 5. There we go. They're different, so we take the difference, and we should end up with negative 1. Very good. Next one. These are like signs. 15 plus 8 is 23 plus negative 3. They're different, so we take the sign of the different number, or we take the sign of the bigger number, which is positive. So 23 minus 3 is 20. Okay? If you can look at number lines for these, I mean, go for it. Number lines is what mostly this was about. So I will see you tomorrow. Thanks, you guys.